Hello and welcome to this first session of Data-Driven Analysis in PolyAnalyst. In this session, we'll be going over the purpose of data-driven analysis, and we'll also talk about two of the nodes that are often used together in this stage: keyword extraction and link terms. Let's start by going over the purpose of data-driven analysis. Now, data-driven analysis typically comes after we've performed the data loading, data preprocessing, and indexing steps. And the main purpose of this stage is to get familiar with our data. It's when we're ready to start using some of our out-of-the-box natural language processing tools to explore the data. And this is also the stage when we identify emerging themes or topics, and where we discover important vocabulary. And all of this helps us create resources and develop more targeted questions for the analyst-driven analysis stage. So let's start by going over some of the data-driven analysis tools we have in PolyAnalyst, starting with keyword extraction. Now, anytime we're trying to analyze text in a data set, we need to keep in mind that the words people use are their unique way of expressing their thoughts about a topic. And while the linguistic structure of a language dictates certain words may be more prevalent in the text, the fact is, some words are more informative than others, especially when it comes to capturing the overall themes. And we also know that determining which words are informative often depends on the context. So this is where keyword extraction becomes very useful. So the keyword extraction node is a tool that shows us the words and phrases that are most frequently found in the dataset compared to their usage in the statistics dictionary that you're referencing. So if you're using the default statistics dictionary in PolyAnalyst, the keyword extraction node will help us determine which words and phrases are being used more often than you'd find in typical English. Now, the way this works is that the node performs a frequency deviation analysis, and it's based on our knowledge of other data sets where the words that appear much more often than they should are more likely to be the keywords for your data. The node will then provide us with a ranked list of these words, and it will construct a word cloud visualization to summarize the themes. Now, we mentioned how context plays a role in determining which words are more informative in a given data set. And this is where it's useful to go over the benefits of using custom statistics dictionaries versus using the default English statistics dictionary. For example, in datasets comprised of typical English, you're much less likely to see the word claimant, whereas the word motorcycle may appear more often by comparison. So if we use the default statistics dictionary for keyword extraction in a dataset comprising insurance claims, the word claimant will be having a very high significance, even though it would not be considered a particularly informative word in an insurance claim. In contrast, the word motorcycle would not appear as a keyword because its frequency in our dataset doesn't really deviate much from the frequency in typical English. However, if we use a custom statistics dictionary that's generated from insurance-related datasets, in other words, if we use a domain-specific dictionary, we'll have very different results in our analysis. So, based on the frequency of the word claimant in insurance domain datasets, this word would not be considered a significant keyword in our dataset. However, a high prevalence of the word motorcycle would be considered significant in this case, perhaps indicating that the dataset contains a higher number of claims for motorcycle accidents, for example. Now, you can generate this type of custom statistics dictionary directly from the index node, and you can refer to the indexing video for more details on how to do this. So we just went over how keyword extraction helps us identify important keywords in our dataset. But we might be wondering if those keywords are co-occurring with certain words more often than others. So to answer this question, we can use the link terms node. The link terms node calculates the correlation between keywords and it presents those in a visual manner like what you see on the right. And these visualizations highlight those keyword relationships, and they help us identify higher concepts in the dataset. Now, the linked terms node uses a modified correlation algorithm that's a little different from the standard Pearson coefficient, which is the most frequently used definition of correlation. And for more specifics and details about the algorithm used in this node, you can consult the PolyAnalyst user manual. But for now, let's get some hands-on practice with these two nodes. Let's start going over some of the data-driven analysis nodes in PolyAnalyst. Now, the dataset that we'll be using for this hands-on practice contains hotel reviews, and this data has already been imported for us, so let's take a quick look. Now, the reviews in this dataset are for a number of hotels in different regions. We also have demographic information about the reviewer and their purpose of visit. But for this exercise, we'll be working with the comment column here. So you can see that we've already completed the data preprocessing part, which is in this group node here. And as you can see, we've indexed and processed the text comments using the spell check node, and we've generated a data set with the spelling replacements. And we've also re-indexed the text comments. So this is where we will continue with the data-driven analysis. First, we'll try to identify keywords in the reviews so that we can get a better idea of what the guests are mostly talking about. And for that, we'll need the keyword extraction node. So let's grab the keyword extraction node from the node panel. I can find it very easily by typing the name of the node in the search field. So now our node is in our workspace and we can connect it to the rest of the workflow. For the time being, we are not going to change any of the default settings in this node, so let's execute by double-clicking on the node. Now that it's successfully executed, we can view the results of the analysis. In the first column, we have the identified keywords, and you can see that when we click on a keyword, we can see all the records where that keyword was found by viewing the drill down section here on the right. We can also see that PolyAnalyst has normalized the values so that we just have the base forms of each word. So for example, we have the normalized value room as the listed keyword, even though the word appears in the plural as well. The next three columns here include the statistics for each keyword. So let's talk about support and frequency first. Support indicates the number of records where this keyword appears, and frequency refers to the total number of instances of the keyword. Now, since we may have more than one instance of a keyword in a single record, the frequency number is usually higher than the support number. But the statistical value that we're mostly interested in is the significance. Now, significance is calculated using a mathematical formula that's based on the ratio of support in the dataset compared to the statistics dictionary. So, for example, we see that the keywords with the greatest significance, like room, staff, and hotel, were used much more frequently in this dataset compared to the statistics dictionary, which in this case is based on the default typical English. Now, we could go through this table here to check the statistics of each keyword, or we can switch to the keyword cloud view where we can quickly identify the important keywords based on their size and color. So here's what the keyword cloud looks like for our dataset. And we can click on any word in the keyword cloud to drill down to the dataset records that these appear in. So for example, we can click on staff and view the records associated with that word on the right. Now, by default, the color of a keyword is based on its support value, and the size of a word in the keyword cloud indicates its significance. However, we can always change what is visually represented and how by using this toolbar here. So if we want the size to correspond to the frequency instead, we can just select that option from this drop-down menu. We can also adjust the word cloud by changing the range. Or we can change the colors by clicking on these circles and selecting different colors. Now, what we might immediately notice about the words in this keyword cloud is that all of the identified keywords are nouns. And if we switch back to the table view, we may also notice that some keywords listed in this column are in different colors. So for example, the green color indicates that the keyword is an existing phrase in the knowledge base of PolyAnalyst, and the purple color indicates that PolyAnalyst found synonyms for that word. For example, if we click on air conditioner and then click on the synonyms tab down here, we can see that PolyAnalyst found that air conditioner and air conditioning are synonyms. So these words are grouped together under the same keyword. Now, if we don't want PolyAnalyst to find synonyms, or if we want PolyAnalyst to identify other parts of speech in addition to nouns, we can configure these options in the node settings. So let's open the node properties, where we'll be able to change the settings based on our preferences. Once we're in the properties, we can start by clicking on the Options tab. Now on the top left, we can choose the parts of speech we want the node to analyze in our text. So let's also select adjectives to be included in our analysis. Now we have several other options right next to the part of speech panel here, like analyzing negations or merging single root keywords. Now if we don't want PolyAnalyst to find synonyms, this is where we would uncheck this option. But for now, we'll leave it as is for our analysis. And on the bottom left, we have a number of options for filtering out things, like junk terms or URLs. Finally, if we want to use different dictionaries than the ones used by default, for example, perhaps we wanted to instead use a custom statistics dictionary, then we could navigate to the Dictionaries tab here and adjust the selections. Now, for most cases, the default settings are all we need. But if we want more control over our analysis, these are the types of settings that can help us fine-tune the node to our specific needs. So let's re-execute our node with the new settings and see the results. And when we look at the results now, we see that adjectives are included as well. So we see that excellent, friendly, and helpful are also among the significant keywords in our dataset. But we might be wondering if some of these nouns and adjectives co-occur frequently with certain words in our dataset. So what are guests saying about the room or the breakfast? What do they find excellent? So this is where the linked terms node can help us. Once we've found our keywords, we can analyze the correlations between those keywords with other words. And we can do this by adding a linked terms node. Now, we could do this by adding the linked terms node from the node panel, but we can also directly generate one from the keyword extraction node. And we can do this by opening the results view of the keyword extraction node. Now, if we click on Generate on the toolbar here, the node gives us several options. It allows us to generate a number of things in addition to a linked terms node, such as a taxonomy to continue with our analyst-driven analysis, a data set that lists our keywords and their statistics, or a derived node with either Boolean or frequency values for each of the keywords per record. Now, the latter is very useful, in fact, for machine learning tasks. But for now, let's click on linked terms. And when we click OK, we get a message that our link terms node was generated successfully. And once we exit the keyword extraction node, we see a link terms node is now connected and ready to be used. So let's go ahead and execute the node. So the link terms node presents keywords and their correlations as a graph. And each circle in the graph represents a keyword. Now, when we first execute this node without changing any of the default settings, we might see something like this, where the number of circles is far too dense for us to make out any of the correlations. So one of the first things we'll want to do is adjust some of the settings on the toolbar, such as the range of keyword results that we can see on the graph. Some of the ways we can do this are to click on the circle here and drag it, or we can type in a target value. Now the toolbar also allows us to select from the drop-down menu which statistic to use. Now the default option is set to tension, which is a derivative of the correlation coefficient. But you can also use support, which is the number of records a specific keyword pair appears in. Now there are several options in the toolbar that control how our graph looks, such as the layout button here, which lets us choose how to arrange the circles of this graph. So let's select the first option here and see how that looks. And if we don't want this layout, we can always choose another one, or we can just click the Perform Layout button here to reset it to the original view. And we can also move our keywords around manually if we want, like this. Now, once we have a good view, we can start analyzing the links we see. And we can click on any of the circles here to see only the links between that word and other keywords. And we can also choose specific keywords from the drop-down list on the toolbar here. So for example, if we select staff, we can see that it frequently occurs together with helpful, excellent, friendly, and so on. Now, if we want to see more details about the keyword links that we identified, we can switch to a table view. And in here, we have the keyword pairs that were identified, along with the tension and the support values for each pair. And if we want to further drill down and view the records where those appear, we can right-click on the pair that we're interested in and click on the drill down option. And this view will automatically switch to the drill down tab so that we can browse through the records where these two keywords appear together. Finally, we can also see the keyword pairs in a word cloud format by switching to the Link Terms Cloud tab here. Now, for most cases, we don't need to change the default settings in the node, but there are some options to help us refine our analysis. And we can do this in the node properties. And let's go to the Options tab. Now, at the top of the Options tab, we can choose the scope of our link analysis. By default, the node searches for co-occurrences of 2 words in the entire document. But we can alternatively choose to search within paragraphs or sentences. So let's go ahead and select sentences. We can also select the minimum number of records that a keyword pair should appear in. Now, by default, it's set at 2, so let's see what happens when we change it to 5. And we can also stipulate the maximum number of links that the node looks for. Now, by default, this is set to 1000, and for now, we'll just keep this as is. Okay, so let's re-execute with these new settings and see how the results change. And now we can see that our graph is much more refined. For example, we now see that the keyword links for room have changed to be a bit more focused than they were before. Thanks for watching this session. Next up, we'll go over another data-driven analysis technique called text clustering.